Okay, hello everybody. Back to calculus and statistics. This is week number 2. We're still talking about type of series and test pair convergence. We last session the topic covered the arithmetic progression. Today another series or progression, which is geometric progression. We go in the same way of the discussion. We'll talk about the definition, terminology, then some of the terms, and then examples, exercises, and then applications. Now, geometric progression, also a sequence or series, okay? But here, there is a ratio between any two successive terms, which is called R. You remember in arithmetic progression, there is difference between the successive terms. Here we have a ratio R rather than D. So you can see, as you can see here, okay, you can see here we have R, which is the each term divided by the previous term. Example, this is, as you can see, sequence. This is item number 1, number 2, number 3, 4, 5. Item number 1, always we call it A, right? And the common ratio is we divide 2 by 1, as you can see, it gives 2. 4 by 2, it gives 2. 8 by 2, it gives 2, and so on. We call this as R. Since we have A and R, then geometric progression written in this way, the first item R to power 0, which means I only, because R to power 0 is 1, A R to power 1, A R to power 2, A R to power 3, and so on. So we can put it in a general form to be the item number n, its value equal the first item, which is A, multiplied by R, rises to power n minus 1. Let's take example. Now, he gave me here arithmetic progression, which is this one, and he told me find the 8th term. It means U8, okay? Now, A is 1, 2 over 1, 4 over 2, 8 over 4, and so on. So R is 2. Okay, you see here, A is 1, R is 2. And he asked me to find the 8th term. 8th term, it means U8 equal A R to power n minus 1, which means 7. As you can see here, A is 1, R is 2, n minus 1 is 7. Do the math, use the calculator to find the 8th item. So this is the first item, second, third, fourth, fifth, sixth, 7, 8. 8 item here, okay? Now exercises to be solved in the class later. Now for the item we define a formula which say that un equal a r to power n minus 1. Done. Now let's go for the sum. Sum, if we want to sum geometric progression, then we will say we will add items, first item, second item, third, and so on. As example here, evaluate. This is, let me say, arithmetic progression. Sorry, geometric progression, let me say. From item number 1 to item number 5, sum 3 and 2 to power n as example. Then this means that we need to substitute for n by 1, 2, 3, 4, 5 and do the whole calculation. Imagine you have 1,000 or million items. It's time consuming. It's not the proper way. So we need to drive a formula. So let assume I'm gonna drive formula to be general formula and use it. We have 5th item in a geometric progression, S5, equal A plus A to power R plus A to power R2 plus A to power R3 plus A to power R4. Now if I multiply by R, then all items left hand side and right hand side to be multiplied by R, as you can see here. Let's say I will subtract them. S5 minus R S5. It means this one minus this one. As you can see here. You see there is sort of similarity between items. So if we, here, don't forget here minus. If we subtract the similar items, what is left is this formula. I'm still driving general formula. Now here this formula, what I will do, I will take S5 common from the left hand side here and we have 1 minus r equal a also taken as a common, a 1 minus r to the power 5. Now divided by 1 minus r both sides of the equation, we have s5 equal a 1 minus r to the power 5 over 1 minus r, which tell me that Sn, the sum, equal to a 1 minus r to power n over 1 minus r. Now when the formula here, when r is greater than 1, then the part here will be higher than 1, and the part here this will give me negative values, so we can reverse them directly or take it, because minus will be plus at the end. Now the previous let me say example, we will solve it using the formula. Rather than we do the math for each item here, we directly go to the formula. We will say that let's assume a is 6, okay, and r is 2 and n is 5. Then substitute here, as you can see here, 6, which is a, r is 2 to power 5, okay, minus 1 over 2 minus 1. Now do the math and come up with the solution. Now another example, find the sum of the first 20 terms of geometric series. As you can see here, we need to find a, this is a, which is 2, and we divide minus 6 over 2 to give me r, which is minus 3, okay. Now I have a, I have r, I go to the, by the way here r is minus 3, so we use the first term, the first formula, okay, for the sum. We will say S20 equal a 1 minus r to power n, r is minus 3, and here also minus 3 to power 20. We use the calculator to do the math, and then we find the solution. You need to work here in steps. You have different items, you have exponent or power, so you need to make sure no mistaking. He told you in the question the common ratio should not equal to minus 1. So what options I got? Minus 1 or plus minus 2. So I will cancel this one. I will take only plus minus 2. Now let's summarize the discussion here. Geometric sequence or progression is coming in the form a plus ar square and so on. Or we can write it in a general form. The item n, its value equal to a, the first item, r the ratio, common ratio, and rises to power n minus 1. Now for the sum of the n term, now we have here the same formula, but it's related to r, if it is greater or lower than 1, positive it mean or negative, okay, smaller taking you to small value or to higher value, because this will reflect on the sign of s. So a 1 minus r to power n over 1 minus r, or just rotate, let me say, or change the places of r in the formula. Now if we want to know the sum to infinity, it means all items of the series, okay, to the infinity. So we write it in this way, s infinity. Then for r lower than 1 small, okay, we can have value for this, because if this is small lower than 1 rises to n, it will go to 0, it will be small and so on. So this part to be cancelled, okay. So we left with s to infinity equal a1 over 1 minus r. Exercise to be solved in the class. Now for geometric progression, as example this one, just to make it in steps, the first item is a, as I mentioned. We divide the second by the first, third by the second, fourth by the third, and so on, as you can see here. 4 over 1, 16 over 4, 64 over 4. Since it's the same ratio, then we say this is geometric progression. If we want to multiply, to look to the next item, then we need to multiply by r. Always multiply, because it rises to power. It means as example, when I have A10, it will be, sorry, U10, it will be A R to power 9. What about 11? U11, it will be A R to power 10, right? Because n minus 1. So it means it is the same previous one, just multiply by R, right? So always we multiply by R. Since R is 4, we multiply by R. We take this to the next item, multiply by R, next item, multiply by R, next item, and so on. And this is the common formula, which say that the item, nth item, equal the first item, R rises to power n minus 1. Now let's see this example. What is the 8th term of the sequence 1000, 500, 250, 125? Now the first item is 1000. This is A. We need to see the ratio to make sure that this is geometric progression. So 500 over 1000, 250 over 500. You see, I'm dividing. It's the same, which is 1 over 2. So R is 1 over 2. Now he asked me to find the 8th item. Then I will say A item, 8th item. So as you can see here, A, which is the first item, multiplied by R, which is 1 over 2, we got it. N minus 1, so 8 minus 1, it becomes 7. We do the math, use the calculator, but make sure that you do the right operation. A equal 5, R equal 3, then we need to substitute 5, 3 to power n minus 1. This is the new formula for this geometric progression. Now he asked me what is the 9th term. 9th term, it means n minus 1, it means 8. 9 minus 1, 8. We do the calculation using the calculator. The 4th term of a geometric sequence is 125. 4th term, A4, is 125, which is AR to power 3, right? The 10th term is 125 over 64. A 10th, which is AR to power 9, okay, is 125 over 64, which is equal to, as I mentioned, AR to power 9. But just a minute, 125 is item number 4, so I can substitute by AR to power 3, as you can see here. Now cancel A with A. R to power 3 cancelled with this one, it will become 6. So what I come up with, 1 over 64 equal R to power 6. Takes the 6th root, we got R equal 1 over 2. Okay, now let me come, what he wants me to find is the item number 14th. So it will be AR to power 13. Okay, which is A 10th multiplied by R to power 4. Why? Why? Because you see here A, or let me say U14 equal AR to power 13. This R to power 13, I can split it into R to power 9, R to power 4. AR to power 9, this one, which is A to power 10, multiplied by R to power 14. I have this one, which is 125 over 64. I have R, which is this one. Okay, now I do the math, I got 8. Now he asked me to find the sum of the 12 terms of the series 101.2.3 n minus 1. This is geometric series. He's supposed to tell me that this is geometric series, but he wrote it in the form. This is A and this is R. Then I will come to say, since R is lower than 1, I got the formula here, A1 minus R, it's supposed to be, which is the same because I just introduced the bracket. Okay, so we substitute for A by 1.2 and R by 0.3 and S, it is up to 12. So we have here 12 and we do the math using the calculator to find the sum up to 12 items. Find the sum of the first 5 terms of this series. Okay, now R, we make sure that it is geometric, so we divide 5 over 3, 15 over 5. It's found that R is 3. We have formula to calculate the sum, So we just need to substitute by A, as you can see here, okay, which is this one, 5/3, and R by its value, which is a 3, and we do the math, we got the sum. Exercise to be solved inside the class face to face. Now let's go to the applications. Have a look. A ball is dropped from a tower. The table shows the height of the ball bounces which form a geometric sequence. What is the height of the 6 bounces? As you can see here, this is the first item, the second item, the third item, and the height in centimeter are given here, as you can see here. Now we will divide 150 over 300.5, 75 over 150.5. So we have also R. A is the first item, we have a 300, and now just we need to substitute. You know the formula, UN equal A R to power n minus 1. That's it, just substitute, you got the solution. As you can see here, this is the formula. A is 300 from the table, 0.5 we got it, which is R, and n is 6 minus 1, which will be 5, and use the calculator to find the bounces. I will stop here to continue in the class face to face. Thank you.